Hello everyone and welcome to a section titled Implementing our Game Logic. In this section we will learn how to implement the necessary logic for our memory game using Visual Studio for Mac and C#. We will learn how to create an instance method that will be used to build our game board and create each of our game tiles using the images from our array. Next we will create an instance method that will randomly shuffle and arrange each of our game tiles within our game board. We will learn how to handle touch events to determine when a game tile has been tapped within the game board, and then create an instance method to compare the chosen game tiles within our game board to determine if they match. Lastly, we will implement each of the remaining game logic methods within our view controller class to complete our game before building and launching our Match the Tiles game using the iOS simulator. So let's get started. Creating the game tiles within our game board. In this video, we will implement the necessary logic within our GameBoard class to construct the game board for our Match the Tiles game. We'll begin by implementing the code within the Create GameBoard instance method that is located within our GameBoard class, and then specify both the width and height to use for each of our game tiles. Next, we will create each of our game tiles using the images from our GameBoardObjects array, and then add these to our GameBoard UI view. So let's jump over to Visual Studio for Mac and see how we can achieve this. So within Visual Studio Community 2017 for Mac, ensure you have the Match the Tiles solution currently open. And then what we're going to do is to implement the code within our Create GameBoard instance method. So firstly, I'm going to hide our solution window so we have some more space to work with. So the first step, what we do, we specify the tile width and tile center values to use for our tile. So we set up 3 float variables. And then for our tile width, we use the game width divided by the board grid size. And then we set the center to be the tile width divided by 2. So we do that for the X and Y for our center. Then we initialize our image counter position called image index. Next, we build our game board with images from our array. So we have 2 for loops. We have a row and column for the board size. So we iterate from 0 to basically our board grid size. Next, we create a new instance of our image tile or game tile. So that should be game tile. So we basically create a new instance. We pass in the row and column, and we create that as a variable called tile. Then we use the GameBoardObjects array from our game tile class, and then we get the image for our image index. So initially our image index is 0, so we get the first image from our array, and then we assign that to our image property of our tile variable. And then we do the same thing for our center property. So we use the CG point for our tile center X and center Y. So if we jump over to Google Chrome, we'll get some information of what exactly is the CG point structure. So it's part of the core graphics namespace, and essentially a CG point is a structure for defining a 2D point. So if you type the following URL in your address bar of your browser, you'll get the following page. And then within this section, you can read it at your own leisure, but there's a series of public constructors. A lot of these are overloaded. So we have a CG point, you have a double, you have a float, and a single. And you have a series of public methods available to you and public operators. So I'll let you read that at your own leisure. So let's jump back to Visual Studio and continue from where we left off. So next we basically convert the image tile into a circle. So we define a variable of the tile image view. Then we call the create circle instance method of our tile variable, which is within our game tile. And then we set the tile width, and so basically the width and height to use for our circle. So we basically -5 from our tile width. And then we set the user interaction enabled property to true. So essentially this will allow us to tap on our image view. If we set this to false, we won't be able to tap on that. Next, we store our tile coordinates within our ArrayList object. So we basically use the add method of our game tile coords ArrayList to add our CG point. Then we add the tile to our tile images array. So we add our image view to our tile images array, and then we add the game board view. So we use the add subview method of our game board view, which is of UI view, to add the tile image. So if we jump over to Google Chrome, some information on the add subview. So if you paste in the following URL to your address bar, you'll get the following page. So the add subview method is part of the UI subview namespace, and it's part of the UI kit as well. So essentially a add subview adds the specified view as a subview of this view. So of the view that you're adding it to, will be added as a subview. And you can also see there's remove from superview, and there's also the subviews. And on this page, there's a series of parameters, some remarks. There's also other methods, and there's a diagram as well to show you the sequence of calls resulting from a call to a UI subview.add subview method. So I'll let you read that on your own leisure. So let's jump back to Visual Studio for Mac and continue where we left off. So next we increment to the next tile position and image within our array. So we basically do a calculation here. So we set the tile center X to the tile width. So we're basically setting the position between each tile within our game board. And then we increment our image index to the next image within our array. And then we have a if condition here. So we check to see if we have reached the end of our row. We essentially reset our image index and then start again. And then we basically reset our tile center X and Y coordinates here.